Oh, it's so cool, it's working. Everybody's been asking us, does the FPV RC Wingsuit MKII actually fly? Today we get the data in the wind tunnel, and the episode starts right now. Smoke on. Camera feed coming in from his FPV. Right. Okay, so behind us here we have the wind tunnel because we're going to be doing some aerodynamic testing with the FPV RC Wingsuit MKII. I'm Richard. And I'm Harry. Thanks so much for tuning in. Let's go and flight test. Here we go. So we got on the wind tunnel and we're going to do our control test, which of course is 0 degrees, just like we did with the Mark I and Mark III wingsuits designs when we put them in the wind tunnel. So first and foremost, let's get the control. There is the Mark II, and there is the giant VTOL propeller on the other end. So there you go, he's sitting in configuration. So now we're going to go and turn it on. 12.6 is what we're going for. Okay, here we go. And we're using a wind gauge, and we are booting up the wind tunnel. Yeah. Okay, so it's 1.407. Next speed is 22.5 kilometers an hour. Okay, so it's 1413, 1412. So same speed, no change. Okay, so last one is 1.416, and we're going to go to 16.5 kilometers an hour. 1416, 1413, 1416. Okay, cool. So that's first round done. That's the control, yeah? That's the control, so and consistent. So no lift generated on that one. Oh, man. Okay, so we need some more tape to complete this experiment. I can get some. Be back in a second. Okay, got some. All right, let's get back to it. Okay, so what's happening, Richard? We're taking them off to adjust the angle of attack, right? Yeah, so at the moment 0 degrees, and we're going to lift it up to 15, which is the second test. We've got a little safety line that we added from our last test. When we were doing the Mark III, right? Yeah, and sometimes it might fall off. So this time we added a little safety, and where that goes from the back to the top. It's not under any load, it's just as a safety backup. So what we're going to do is reset this guy, and we're going to go to the 15-degree mark to see if there's any lift generated under these wings. But so far, the control has been consistent, so we'll get into the next phase. Okay, so it's a new day and we're competing. We're actually rushing because, of course, there is in fact a cyclone coming to New Zealand, and we don't want to wreck the results of this test and keep it accurate. So we're going to jump straight into it. We're going to go as fast as we can to get it done in the time cap, because obviously it's a cyclone and it's not exactly specifically on 1 hour or another. So we'll get as much as we can done. The control was done yesterday, and that was at 0 degrees, right? Yep. So we're going to bump it up to 15 degrees for this one. So yeah, 15 degrees is there, and that's where we're going to put the man. So he's going to be 15 degrees, effectively like that, and he'll be facing into the linear air as it comes and gets pulled through the propeller. All right, so we're just going to tape down a little GoPro so it can capture this dial and what's happening on the scales in real time. 12.6 kilometers an hour at 15 degrees of inclination. 1499. 1499. 4 was 1506. So the next test will be at 16.5 kilometers an hour. Yep. So we're sitting at 1514. 1504. 09. 1509. So now we'll go to, oh, hang on. What? It's gonna, is it moving? Richard! Okay, safety has caught it. Oh no. Okay, lucky safety gauge was in. You can see that wire holding it, it's just got a little bit askew there. I guess it's not really taped on that well, but for these tests,
It's good that we put a safety line in, and then we'll reset that one. And we'll go again. And we've disconnected the batteries, so we're safe. People ask us quite a lot, is your safety, are you 100% safe? 3, 2, 1, go! Yeah! Welcome to the H.I.J. Racing Show! And we are your hosts. I'm Harry.
And I am Richard, and thanks very much for joining in on this exclusive series. This is the FPV RC Wingsuit Mark II edition.
And we get a lot of comments and people sending it in across all the platforms saying, when's it going to fly, when's it going to fly? Well, that is today, and the next time you see this particular one, he'll be in the air. But we need to get the most critical information now in the wind tunnel, so when we go to fly it, you know, it goes through with a breeze because it's a prototype aircraft and not just one off the shelf.
That's right. So of course, we're at the very beginning. We designed this particular aircraft. We brought it through all its paces: assembly, parachute calculations, sewing all the suit, and of course, the last time you saw this guy, he was doing flight modes. Gliding mode, we had tracking mode, and of course, steering under canopy. All those kind of things are all engaged into this guy, and of course, he's got FPV camera, action camera on his head. You can see through the eyes of the wingsuit why he hurdles down the hill.
Yeah, that's what it's all about. And this is not the only design we have made on the channel. We've also made the Mark I and also the Mark III. Both different designs, but still nonetheless our designs. Well, it's effectively us in these planes. If you haven't done it already, make sure you give the thumbs up, subscribe, and of course share.
Okay, so of course we're going to go and get the data. We're going to compare those results against the Mark I results and Mark III at the very end of this video. So stay tuned. It's going to be exciting. Let's get into it.
So 1.494.
Okay, and what's the speed?
22.5 kilometers an hour. 1495.
1495. She was pulling air there, wasn't she?
So that one done.
So then we need to go up to different degrees of...
Oh, safety caught it. Richard, I wonder why Richard was moving. About a Kiwi ingenuity.
So this is 30 degrees inclination.
We're doing a 12.6 kilometers an hour. Okay, I'll just measure what it is beforehand. 1.483. 1.78. 1.78.
1.78.
We're going up to 16.5 kilometers an hour. They're measuring it. 1.485. 1.83. The last one is 22.5 kilometers an hour. If you wanted to know what Rich is doing, he's increasing the speed and measuring from this gauge. Which is this gauge?
It's a wind meter, so we've got it in kilometers per hour.
And he's just putting it over the end of the propeller here and getting the results and measuring it off that way. So he is sitting at 1.496, 30 degrees inclination, 87.
All right, we got it finally.
There you go, tricky, but again, there goes. Next to our sides. Okay, so we're just getting ready to put the smoke machine in there to see what the effect is going to be at this 30 degree inclination. We're just waiting for it to warm up and then we'll be away.
And what's the weather doing out there?
It looks like it's getting worse, so hopefully we can get these tests done before that sets in. Okay, there's the big 200 amp ESC with
V9626 at 160 kV.
And a 32 inch, and we made that in a previous episode, so make sure you go back and check that out when we made this wind tunnel. Smoke on in 3, 2, 1. There you go. You can see it running over the arms. So what would you say? Would you say that's stall speed, Richard?
Yeah.
Very cool.
A lot of smoke around.
Yeah.
So that's yeah, that's showing lift. So that's the 15 degree slight angle here.
Ooh, and it's ripping along that arm there. And away she goes.
Okay, so this is the control. We've got them horizontal or zero, if you will. You see that?
Whoa. Whoa, cool. Okay. Seeing it going straight through there. Very cool how it's going through like that. Very cool. Very sleek, very sexy. This time around, we've got him all plugged in and ready. So what we're going to do is we're going to test the flight characteristics. Remember, in previous episodes, we have programmed him to do flying mode with wings out, so he can turn and fly like that. Can also change into tracking mode by turning his arms and going in, and also doing air brake as well. So there you go. So that's what we're going to be testing. His legs go up and down for elevator.
Also, most important, we're going to test stability. So you've seen those little air pockets have any effect, like when the results from the Mark I,
Yes.
it proved really successful. So we're hoping that this will have the same result.
We've got a safety wire in there, but you can see that there's one that's loose, so don't worry about him, he's not having any effect, and the other one just to hold him in that 15-degree incline of attack. That's the plan. So we're going to plug it in, and we're going to check the FPV feeds coming through. We're going to check the controls. We've also changed the configuration. We moved the tunnel from here to there, and this time around we'll be blowing air across it, and that way he's flying into wind. Well, let's go and see if the Mark II wingsuit can fly.
Welcome to OpenTX. Throttle warning. Fixed wing.
Hey, look at that.
Let's see if he has controls. They're right, left, up, right, left. Okay, cool. See if the FPV feed is coming in. Okay, so you can see that there coming in from his head. There you go. So he's flying directly towards the VTOL engine right there. Going left, you can imagine. Going right, you can imagine. Then up. There you go.
I thought you were holding on, but I'm just reaching into empty space. Another day where you slip further away.
So remember, instead of pulling like it was before, now it's pushing it towards him. Right, it's stable, Harry. It's stable. It's totally stable. Have a look at that shot. It's awesome.
Yeah, Ian's going into the suit. Ian's going into the suit. Whoa, that's so cool. It's just like we designed it. The air is inflating into the suit, and that's where it's at. We're going at 9.5 kilometers an hour. 8.6 now, 9.3.
Give him a wiggle just to see if he recovers after stability. Does it?
It does. Oh, it's so cool, it's working. Oh, it does. There you go. So when we did that with the
Mark I, it did it really well. So that's the air pockets come into effect. You can really see the lift under there. So go to the right. Yeah, it's coming right.
and left.
Yeah. Yeah, and up and down. Up. It'll start nodding. Yeah, it starts nodding the other way. Yeah. Yeah,
It's
there you go.
nodding. So watch this. Up. So it starts nodding. There you go. You can see it there quite prominently. Nodding.
Yeah,
That
and
means
then there's a camera feed coming in from his FPV.
on his head. To the right.
Yeah, it comes towards us. And then left.
And left.
It goes to the left. Okay, it's at 13 kilometers an hour.
Okay.
14.
Left.
Yeah, it's
Left.
working. Yeah,
Up.
right.
It should nod.
Yeah,
It's
nodding.
nodding. And you can see the air going into the suit.
Woohoo!
To the right. To the left. Up. And down. 19.8 kilometers an hour. Up. There you go. It's nodding like that. And to the right. Yeah,
Yeah.
it's turning into the wind there, and left. There you go. Cool. To the right. Oh
Yeah.
yeah, there
it's
you
good,
go.
yeah.
And left.
Where are you? I'm looking for you everywhere. Is this all just happening in my head? Were you even real?
That was pretty successful, right?
Yeah, I think it was pretty good. And also you could see that if you were looking carefully in that last shot, you could see that the suit was popping as the air goes inside, which is what we want with inflation on them. That means that we sewed it right.
Yeah.
So up to this point, we didn't know.
Okay, so what's the next step?
Just a little test to see how the arms are working in the next configuration, which is the tracking mode.
You want to see if does that have any effect with the wind as well, because we don't know yet.
We don't know, yeah. Okay, so let's change into the next mode.
Speed mode.
Whoa, that's so cool. I never get bored of looking at that. It's cool, and it still has the same thing, which is right and left.
Yes, but they do move slightly differently, right?
Yes.
So instead of going up and down or side to side, they move backwards, right, and forwards.
There you go. So that's it in tracking mode, if you will. And if we do air brakes, this is what it would be like, a flare mode, if you will.
So this is under canopy. You wouldn't use it in this mode.
No, but this is what it does.
Flaps full.
Yeah, so that's pulling the chute, as it were.
Yes, so it would be pulling on the chute. So let's go and test that. So it will be doing the same thing, going to the right, going to the left, and there you go. Okay, so we'll go back into normal flight mode.
Fixed wing.
And we'll see what that's like. Okay, use speed mode in 3, 2, 1, now. Whoa!
Oh, okay, so it changes it quite a lot. See, there's a lot more air being lifted under the suit.
Okay, so how does that affect controls? Let's have a look. To the right, oh, okay. And to the left. Yeah.
Oh, it does have an effect. Interesting.
We're going up elevator, you should see a bit of porpoise action. There he goes, dipping like that. Okay, to the right. He's coming around, and to the left. There you go, cool.
It does.
Okay, going back to normal mode in 3, 2, 1.
Fixed wing.
Whoa.
Tell me where you are, need you here, out here under the cold city lights. You were the spark that kept me moving. Where are you now? I can't hear you anymore. Where are you now?
Okay, so there you go, guys. It's been quite successful so far on this wind tunnel test. We have managed to check the flight characteristics so far. And what do you think so far? Can go right and left, Richard? What do you reckon?
It's more prominent than the Mark 1.
Yes, so there's definitely a bit more of a kick on the design. When he moves his arms, you can definitely see that he turns into the wind. When he goes the other way, he banks the other way, which is what we want to see. When the legs come up and down, the head starts to porpoise, so therefore it shows that's happening. So that's good.
And also the air pockets, which is sewn into the suit, they were having an effect, just like the Mark 1 as well. So
Stability, he was keeping himself straight. When we found on the Mark 1, for instance, the improvement up to Mark 1 is that's what that did. It kept it straight. So that is true on the Mark 2. So that's good. What do you think about the tracking mode?
it seemed to be quite well. Acts a little different. So instead of moving up and down, as it were, now he's going horizontal movements to himself and away from himself.
There was a bit more of, you can see a bit more of a swirl in the suit itself. So it's going to be interesting to see what the smoke trails do to this. And so what we're going to do next is go and turn the smoke machine on, and let's go and have a check. Let's go and see what the flight does. And smoke on in 3, 2, 1.
Oh, that's cool. Okay, adding some movement to the right.
Oh, it's definitely changing this. Oh yeah, you can see that. It's definitely having an effect by changing his arms.
There's the elevator going.
On the flight dynamics.
Oh, yeah.
Okay, very cool. Whoa, cool. Okay, so there you go, guys. Saying that, there's a lot of smoke, a lot of aerodynamics and stability tests. So let's go and look at the results at H&R Drone Racing HQ. so there you go, exciting stuff to see at flight testing. That's what it's all about with the Mark II FPV wingsuit.
Yes, and of course we've got a lot of good data we're going to be checking out very shortly. And the next time you see this, it will be in the skies, flying down, trekking down the hills.
Yes, so stick around for that exciting stuff. And if you haven't done it already, make sure to subscribe to see all that coming up. Okay, so saying that, let's go and look at the data that we just got.
We did ultimately three main tests. There's a couple of sub-tests in there as well, but they are the lift generation calculation, smoke trails, so the 0, the 15, and the 30, and we did the flight characteristics. Is it stable? Can you turn? Can you left bank up and down? First and foremost, let's dive into the lift generation calculation. We're going to compare all three wingsuits at the same time. So we've got the Mark I, Mark III, which of course we did on previous episodes, and we've got the current one, which is the Mark II.
You can see the angles of attack. We did 0 degrees as the control, so straight on into the wind, and then there's 15 degrees and 30 degrees, which, as we know, getting near to that stall speed. So what was the results in the 0 degrees? No lift was generated through all three different wingsuits, but that is to be expected, and that is a good thing. That means it's not a flying brick just heading straight to the wing, generating unnecessary turbulence right there. So that is something good. Yes. That means that it is aerodynamic, it is sleek, it is sexy. And then we jump into 15 degrees inclination on the Mark II. There is a little bit across the board, like 2 to 7 grams of lift generated across the board there on the different tests and at the different speeds. 12.6 kilometers an hour, 16.5 kilometers an hour, and of course 22.5 kilometers an hour. And where does it stack compared to the Mark I, Mark II, and Mark III, Richard?
It's exactly where we thought, right in the middle. So
yes.
You start out with the most inefficient one, which of course makes sense because the least amount of wing surface area is of course the Mark I. Small numbers, but they are generating a little bit of lift. Of course, then next comes the Mark II, so the 0, the 15, and the 30, sort of sits in that sort of midsection. The Mark III, which is ultra light, featherweight kind of class.
Yes.
And he of course is generating the most amount of lift. So that actually makes sense. So that means the math makes sense to reality. Just by visually looking at it, you go, that's probably about right. See, more wing surface area creates more lift.
Okay, so there you go, that's positive news. And saying that, moving on to the smoke trail test. So in the smoke trail test, we could see there, again, at the 0 to 15 and the 30 degrees, you were getting some smoke and coming through. You can even see the smoke if you look really carefully going into those little wind air vents going into the suit. So that means that the suit is working correctly and working the way we wanted it to do, just like the real deal, the full size ones, and it's inflating the suit. And as it hits the surface of the shoulder, you can see it forming off and sticking to the surface as it goes down at that 15 degrees inclination.
At 30 degrees, you can start seeing that stopping power, right? So effectively you are reaching that stall speed, but of course visually look quite cool.
Oh, it looks cool, and you can see it just rolling off, and there's a little bit of swirl at the back there, but that is to be expected. So there you go, that is some great news to see there.
Okay, so moving on to the flight characteristics. So this is the one we did at the end. We've engaged the suit. He's got the FPV working. He's got all the flight characteristics that we have available. Effectively 3 modes. He's got gliding, tracking, got braking as well, but that's sort of an aside for, it's actually used for when he's under canopy, but we did it nonetheless just for fun.
You can see as I turn left, he did actually have a bit of kick to the left, so there you go, and to the right. So that was significantly better results than the Mark I.
When he rotates his arms into a tracking mode, the airflow is different because you see that massive billow of the suit now. Not so tight,
yes.
But it is interesting. It still works, even though his arms are in fact moving in a different articulation direction. But nonetheless, it's still having an effect.
It's going to be exciting to see what the effect of that will be in the air.
It did seem like it was a lot more agile.
It did. It might even, I was actually maybe even thinking it might roll.
Okay.
Completely roll over.
Interesting.
And that is cool. I mean, that's what you want. I mean, that's what wingsuits are all about. They flip upside down, then they flip that way. Aerobatics tricks, and that's what you want to see. You want to see that next evolution of FPV. You don't want to just stay in the same thing. You want to push that limit, and that's what it's all about on the channel.
Okay, you can also note that in terms of stability, it is also working somewhat the same as the Mark I, which is great to see, which is what we theorized, and of course now we proved that those inlet valves that we've added that act on the suit, in fact, act like a rudder.
Yes, and we were pushing it. You can see it just turn back into the airflow. So saying that, let's move on to the next segment.
the movie of the week.
And the movie of the week is The Salvation. Yes, a very cool Western movie.
And they've actually kept to the original style, which is always good, because modern day Westerns they always seem to go off on a different tangent, but they actually kept it to the true Western style. So very cool. So go and check it out. Okay, final thoughts.
Yes, for me, it's all about seeing that guy move and do his thing. You do the whole
articulation.
Yes, very
Flight
cool.
modes, yeah, very cool.
And get those important numbers that we need, so when we go for the actual launch, it's good to go. Green light.
Do we need to do any modification based on the data?
I guess leave your comments below if you think we need to change anything, because it's better to change it now, get it all perfect before we send it. So leave your comments below, it all helps.
To thank all our sponsors, thank you most importantly of all. And of course, remember to tune in on our live streams. We're going to be deep diving and doing a Q&A on this one later on in the week. And of course, it's going to be continuing on with the RC Eagle design build that we're making.
You can support the channel on Patreon, and of course, subscribe, share, and like this video. There you go. It all helps YouTube to send it out to more people that like this sort of thing.
It needs that little push.
There you go. Okay, so here we go into next week. I'm Harry.
And I'm Richard. And we'll see each other next time.
3, 2, 1, go! Racing, yeah!